When a pathogen invades the body, lymphocytes are capable of producing antibodies which can result in the destruction of the pathogen. But the problem is there are lots of different types of lymphocyte in the body, all producing unique antibodies, and each pathogen needs a very specific antibody to destroy it. So there's a little bit of time while the body tries to figure out which lymphocyte does it need to destroy this particular pathogen. In the meantime, the pathogen can go on reproducing inside of the body and causing all sorts of damage, effectively making somebody sick. Eventually, the body does find which lymphocyte it needs, and two things will happen. First, cells will be produced that will produce the antibodies, and this will result in the destruction of the pathogen. The person will get better again. But the other thing that will happen is memory cells will be produced, and memory cells are this version of the lymphocyte that stick around in the body and can recognize the pathogen if it ever comes back again. So, let's imagine the pathogen does re-enter the body, maybe 6 months later or a few years later. The memory cell will immediately recognize it, immediately start producing the cells that need to produce the antibodies. The pathogen will be destroyed very quickly, and it will happen before the person is able to get sick. So memory cells provide something called active immunity. It is active within your body. Now, to understand what we mean by active immunity, we've got to contrast it with passive immunity. And let's look at an example of a newborn baby. Newborn babies have got relatively weak immune systems just because they're quite undeveloped. And so it may not be able to produce the necessary lymphocytes to produce the antibodies itself. But one alternative would be to provide the baby with antibodies directly. And this is something that does happen. Mothers provide antibodies to babies through breastfeeding, for example, and they can result in the destruction of the pathogen. If, however, sometime later this pathogen comes back, the antibodies have now gone, which means this pathogen can then start to reproduce, start to make the person sick, and then they've got to rely on building up their own memory cells. So antibodies that are entering the body from outside provide something called passive immunity. This passive immunity is only temporary because it's only providing antibodies that won't last forever. Let's look at a few comparisons. Memory cells are produced in active immunity but not in passive immunity. And antibodies come from inside of the body, produced by the body's own white blood cells in active immunity. But with passive immunity, they come from outside. It might result from invasion of a pathogen or vaccination to provide active immunity, and we'll discuss vaccinations in just a moment. But passive immunity will result from injections. For example, rabies can be treated by an injection of antibodies, and also, for example, breast milk provides antibodies to a baby. Now, vaccinations. Now, if we want someone to be immune to something, they need to have the memory cells produced. Well, let's imagine we could provide those memory cells before a person gets sick. Well, we can do that if the person is exposed to a weakened or a dead form of the pathogen. This will provide exactly the same immune response to the normal pathogen, but of course, with the advantage that the person doesn't get sick. And of course, in some diseases can be fatal. It means there's no risk of death here. So, memory cells are produced and active immunity is provided. And vaccinations can be provided either through injection or they can just be introduced orally. Let's look at a little bit of exam help, something you might get asked on this.